Hi, welcome to Math Beast Tutoring, now on YouTube. Hi everyone, today I would like to do solving linear systems. So now that we've gone through one of the methods for solving algebraically a linear system, we've already gone through the elimination method, which is where you add them together and have either x or y cancel out so you can solve for them one at a time. Now let's move on and let's learn the substitution method of solving a linear system. Again, no whiteboard here. We're going to go into Jamboard, and I hope you like this method. See you in there.
Hi there, here we go. We are let's move on to solving linear systems by substitution. This actually is my favorite method, just because to me it seems like it requires a little bit of less work and it allows me to solve algebraic equations the way they're more fun for me. It's not everybody's favorite, but it is mine. Now I want you to take a special look here. Notice that I've written the equations side by side. Equations that normally they come right on top of another, I like to automatically write them side by side because in this method of solving systems, I want to have either x or y in either equation all by itself. So I'm going to solve for either x or y in either of these equations. I have to choose one. And because I'm going to have to do some solving work, having the equations side by side gives me some space to do that down below it where I like to. So let's see. I think that we're going to solve for x over here on this side because that would take just adding 2y to both sides and I have x. So let's do that. So I will add 2y to both sides. And I'll get my new equation, x equals 2y plus 4. Now, I'm going to put this in brackets. You can use brackets or parentheses. You don't need to, but I'm going to because this helps me know that I'm going to take this entire chunk, this whole chunk of equation, and I'm going to take it over here because it's equal to x. I'm going to take it over here and I'm going to drop it in right there for x. Right in there. So instead of having an x here, I'm going to have 2y plus 4. All right, let's do that. So I will have 3 times 2y plus 4. There it is. I dropped the substitution of the other equation in. Plus y equals 5. Now I have equations with only y. I can solve equations with only one variable. Let's continue. Let's distribute that 3. 3 times 2y is 6y. And 3 times 4 is 12. And plus y. Now I can collect like terms. I can collect my 6y and my plus y. Oh my goodness, I forgot to write equals 5. Equals 5. There we go. So now collect like terms. 6y plus y is 7y. Carry down the rest of this side. Plus 12 is equal to 5. Now I'll solve for y. Subtract 12. Subtract 12. And I have 7y equals negative 7. Divide by 7. Divide by 7. So many 7s. And I have y equals negative 1. Now this is the first bit of our solution. Our coordinate point. And because this is y, that goes here. We need to find our x-coordinate of that. Now, because I did the majority of my work over in this equation to find y, I'm going to plug y in right here in this equation in order to find my x. Okay, so let's do that now. In our red marker, we have x equals 2 times y, which is -1, plus 4. And now I'll just continue to crank out my answer. 2 times -1 is -2 plus 4. -2 plus 4 is +2, so x equals +2. And there's the second bit of my coordinate point, which is the solution to this linear system. Now, if you notice, this was the same exact linear system as we did for the first example where we solved by elimination, and this is the same answer. So 2 methods, 1 answer. And this is our one solution example. Let's move forward. All right, the yellow one. Now this linear system, again, we have it written side by side, even though in this case, this y is already solved for. It's already by itself. So I will just take this and drop it right in there for that y. And let's go for it. So we'll have 2x plus 2 times y, which in this case is -x plus 3. And that is equal to 6. Now I have equations with only x. I can solve this. Let's distribute that 2 into there. So I'll have 2x, and 2 times -x is -2x. 2 times +3 is +6. And of course, carry the rest of the equation down, equals 6. Now look at what's going to happen when I collect like terms here. I have a +2x and a -2x. Those are going to cancel, which leaves me with +6 is equal to +6. Now this is a true statement. Because this is true, this is going to be our many solutions. Because this is true, we have many solutions, which means our graphs are on the same line, and every point along this line is going to work in this equation and this one. Okay, moving on to our last example. Here, again, I have my y. It's in here. It's already solved for y. So I can just take this chunk right here, and I'm going to drop it in right there for y. So let's do that now. So I have now 2x minus 3, and we'll get the rest of the equation. Minus 2x equals 1. So I don't actually need these parentheses, but they are here to show that I have taken the equation from here and I've dropped it in there, and here it is. Now let's just continue to solve. We just have 2x minus 3 minus 2x equals 1. Now again, watch what happens when I collect like terms. I have 2x minus 2x. That will just cancel itself out, and I'll be left with -3 equals 1. Now, -3 does not equal 1, so this is untrue, which is our clue that this is a no solution system. And no solution systems are systems of parallel lines that are never, ever, ever going to cross. All right, that is how you solve linear systems. We can solve by substitution, or by elimination. Either way, we'll find our answer. As you can see, we got the same answer for the substitution method as we did for the elimination method when we add the two together. We may have different components in there, but we still ended with something untrue and untrue, which is our no solution example. All right, just to be thorough, let's go to our graphing tool. Let's take a look at these systems graphically. So again, our blue system, our lines are crossing, and if we scroll in right here, we see that the solution right here where it crosses is -2, 2, -1. Excellent. Now let's check our yellow system. Yellow system, oh man, where's the other line? Oh, that's right. The other line is not there because both equations are actually the equation of the same line. So every solution in here is going to work for both lines. Okay, and then again, our green system, we can see parallel lines. Parallel lines don't cross. So we have no solution.
Thanks so much for watching. Thanks for sticking with me in this new method of filming videos. I hope you were able to understand both methods and always know that the one you're most comfortable with, that's the one you should use. I have my favorite that I use all the time. You'll have yours, and that is perfectly okay. Until next time, stay safe, stay inside, keep your chin up. I love you all. See ya.